Okay, so the last topic for alkyl halides, we're going to talk about organometallics. And what we'll learn here is how alkyl halides are used to make organometallics, as well as how alkyl halides react with organometallics. So what is an organometallic? It's just a compound that contains a carbon metal bond. You can see here this is carbon. M is just a generic for the metal. And notice the dipole arrow is going towards carbon. That means that carbon in this case is partially negative, and then the metal is partially positive. What that points out is this, that carbon in an organometallic bond is a nucleophile. And so that carbon is going to attack an electrophile. Again, if you need to refresh yourself, you can go back and refresh yourself on nucleophiles and electrophiles. Alright, so let's look at some types of organometallics. We're only going to discuss three. The Grignard reagent, which has a carbon magnesium bond. The Organolithium which has a carbon lithium bond. And then a Gilman reagent, or the Cuprate, which has a carbon copper bond. Alright, so let's talk about what organometallics do, because they do what we call coupling reactions, where you can take an organometallic and react it with an alkyl halide. Again, this is my organometallic CM, and let's just say that my alkyl halide is RX, where R is carbon and then X is a halogen. I can take these two and react them together and put C and R together in the product. That's called a coupling reaction. So I can use organometallics to do coupling reactions with alkyl halides to form new carbon-carbon bonds. So this is a bond between the carbon from the organometallic and then the carbon, which here is represented by R, from the alkyl halide. Right? And so the types of organometallics that do these types of couplings, the ones we're going to focus on anyway, are Grignards and Cuprates. There are many other organometallics, but we don't they're outside of the scope of this class. Alright, so when you think about coupling, just use this simple method. You just say look for CM and you look for RX, and those will be your coupling partners. RX will be your alkyl halide, CM will be your carbon metal bond. Alright, and when you think about the coupling, it's just a substitution. It's the equivalent of a substitution. It's just metal mediated, right? So, and remember from organic chemistry part 1, when we did substitutions, we said A plus B, or AB plus CD gave us AC plus BD, right? Where A and C are now bonded together and B and D are now bonded together if the reaction is a substitution. So it's the exact same concept here. The only difference is there's a metal involved, and that metal has a covalent bond to carbon. Alright, so the first type of organometallic we're going to discuss is the Grignard reagent. Very simple, right? The way I make Grignard reagents is if I take an alkyl halide, right, plus magnesium, and I keep that at 0 degrees, and I stir those two together in ether. The magnesium is just a metal. We just take the metal shavings and they're in the reaction flask, and I have to drip in the alkyl halide because this reaction is water sensitive, and so you don't want any water in the reaction vessel. Alright, so if I take an alkyl halide, react it with magnesium metal, I get a Grignard reagent. Well, now I have in between the bond, the carbon halogen bond. If you see here, this is carbon and this is halogen. In between that bond, I actually insert magnesium here. Right, so I have carbon, magnesium, and then the halogen here. Now, if I get this wet, or if I have it around acid, I'm done. Right, this Grignard just simply turns into an alkane, which is not what I want. But I can take this Grignard and react it with another alkyl halide. We'll do some examples tomorrow. We'll do some examples tomorrow. If I react this with another alkyl halide, I can get a coupling reagent or coupling reaction to happen. Right, so that carbon magnesium bond is covalent. The best type of alkyl halide to use is an alkyl iodide, because the carbon iodine bond is really weak. It's a long bond, so it's easy to break. Alright, if you take a primary, secondary, or tertiary alkyl halide and react it with magnesium, you'll get a Grignard. If you take an aryl, right, an aromatic halide and react that with magnesium, you'll get a Grignard. And if you take a vinyl halide where I have a halogen directly attached to a double bond, if I react that with magnesium, I'm also going to get a Grignard reagent. Alright, so here's two other organometallics. One is the organolithium um, organometallic that we talked about earlier, right? So I need an alkyl halide, two equivalents of lithium. That just means that lithium and the alkyl halide are present in a 2-to-1 ratio where I have 2 parts lithium, 1 part alkyl halide. If I stir those two together in pentane, I get an alkyl lithium. These are not very good nucleophiles, but they are very good bases. All right, and we'll talk more about that later. So alkyl lithium compounds, why do I need to make them? Because they're precursors to Gilman reagents or organocopper compounds. So if I take 2 equivalents of an alkyl lithium, that means 2 moles of alkyl lithium, and I stir that with 1 mole of copper iodide, what I get is called a Gilman reagent or a cuprate, where now I have this carbon that was bonded to lithium now bonded to copper, right? And get that not so in this particular organometallic, I have a carbon copper covalent bond, right? This is an excellent nucleophile. It reacts with just about anything. It's a very good nucleophile. And down here I have a reaction of a coupling, an example of a coupling reaction with the cuprate. Let's go through it. So here's my cuprate. Notice I have both of these groups attached to copper now, right? So that's what the subscript 2 is for, right? That red dot you see, that's carbon attached to copper, right? And if I react this with an alkyl halide, just ethyl iodide in ether at 0 degrees Celsius, I make a new carbon-carbon bond in the product. So notice what I just coupled. This is Cm, this is Rx. X is my halogen, R is what's attached to it. So if I take Cm and Rx and react them together, then I should get in the product Cr, which is what this is, and then Mx, right, which is what these two pieces equate to. All right, but notice there's a carbon-carbon bond here, a new carbon-carbon bond that's formed between the carbon that was bonded to the halogen and the carbon that was bonded to the metal. And notice here the subscript is now 1. This Gilman reagent only transfers one of these groups to this carbon and makes the new carbon-carbon bond, and the other group gets left behind. So here's some other examples of Gilmans. Again, they're similar to Grignards in that if you react them with an aromatic halide, in this case iodobenzene, if I react that with my cuprate, and notice the two groups, the two alkyl groups that are on the cuprate, it's simply a methyl group. What I'm doing is, this is Cm, this is Rx. I'm just simply replacing X with the C from the organometallic, right? So now this CH3 group is going to be bonded here in the product. The same thing if I have a vinyl halide, in this case a vinyl iodide, and I react this with a cuprate, in this case a dimethyl cuprate. I have two CH3 groups attached here. All right, if I react this with a vinyl iodide, what I'm doing is, this is Cm, this is Rx, and so I'm replacing X with C from the organometallic, right? The Cm. All right, so this is my product where one of these groups gets transferred here, and we'll talk about this mechanism more tomorrow. It's not as simple as it looks, and so I don't really want to go into it on this particular video, but we will discuss it on tomorrow. So if you have any questions, you can tweet, you can email, or you can call. Be ready to work when we come to class tomorrow, because we're going to hit this really hard. I'm going to bring a lot of different types of questions, and we're going to work through some of these examples so you can get a feel for what's going on. All right, peace.